All right, welcome back to section 15.3, the center of data. We just did a bunch of leveling off in our previous examples, so make sure you didn't miss those. And now we're going to say, how can you quickly calculate the mean of the following list of test scores without adding the numbers? All right, so basically here, let's look at these. All right. We kind of want to start with a random number. When I look at these, I'm certainly not going to guess that the mean is 50. That doesn't make any sense, right? When I look at these numbers, I might start with an idea that maybe the mean is 80. And again, this is a question, but we're going to see if we can look at the distance, how they fall above and below 80, and then we'll see if we can get an average on either side, and then if we're right, and then we'll go over and under as we need. So how far is this from 80? 3 above, 1 below, 1 above, 4 below, and 1 above. Okay, so let's add up all the aboves. So above, we're going to have 3 plus 1 is 5 above. And let's add up all the belows. Think of this as your fulcrum, your balancing point. We've got 1 below, 4 below, 5. So we've got 5 above 80 and 5 below. That's going to balance it. So actually, our guess was right. The mean is 80. 80 is our average. Let's look at another example. A teacher gives a 10-point test to a class of 10 children. Is it possible for 9 of the 10 children to score above average on the test? If so, give an example. If not, explain why. All right, let's think about this for a second. 9 of the 10 to score above average. So if we kind of think about here, if 9 out of the 10 students score, maybe they score a 9. It's a 10-point test, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, just so we can see. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. If the students were to score a 9 on this test, and one student scored, let's say, a 1, what would be the average there? So 1 plus 9 times 9 divided by 10, right? There's 10 students. So what is 1 plus 9 times 9? 82 divided by 10 is 8.2. So did these 9 students score above the average? Yes, they did. And we could do it a couple different ways. What if the student scored a 2 and a 10 or a 0 and they all scored 10s, right? So it is possible. Is it possible for all 10 students to score above the average? Okay, let's think about it. We've got 1, someone could score a 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, is it possible for all 10 to score above the average? Well, 1, 2, 3, 4, 1, 2. I mean, no, because no matter what, we need the mean to be a balancing point. So even if they all scored 10s, maybe the average would be 10. They're not going to score above the average. So the answer is no. The only way we could get kind of close is if we said that if all the scores were the same, it would equal the average, but it'll never be greater than the average because we need to balance it. All right, discuss Jessica's reasoning about calculating the mean of the data displayed in the dot plot. Okay, I took 2 dots from above the 8 and moved, okay, she took 2 dots from the 8 and she moved 1 to the 6 and 1 to the 7. So she balanced it out, kind of like the towers. Then they're all towers leveled out, and they were all 4 tall, so the mean is 4. Okay, is her reasoning valid? Well, let's first see what the mean is originally. So the original mean, or we should say the real mean, is going to be equal to 3 times 6 plus 3 times 7 plus 1, 2, 3, 4, 5, 6. 6 times 8. Over 3, 6, 12 dots total. So let's type that in our calculator. So that would be 3 times 6 plus 3 times 7 plus 6 times 8. Make sure you hit equal and then divide it. Otherwise, you're going to get the wrong answer. So the mean is 7.25. This is the correct mean. Let's see what her mean will be. So that would be 4 times 6 plus 4 times 7 plus 4 times 8, all divided still by 12. So 4 times 6 plus 4 times 7 plus 4 times 8, hit enter, divide by 12, we get 7. So it's not the same. Why? And the reason why is that when we were building our towers, each tower was worth 1. And now these towers are not worth 1. This dot is worth 8. This dot is worth 8. So you can't just move it over into the 7 category because it's not the same as when we had our unit squares. So that's why her valid isn't, or her argument isn't working, because what she did here, so she basically had 6, 6, 6, 7, 7, 7, and she did 8, 8, 1, 2, 3, 4, and then she took these 2 8s and dropped them over here. So she can't really do that because the idea is that it's not the same. It's not leveling out the same. She lowered our total. She turned an 8 into a 6, so we lost 2. And she turned our 8 into a 7, so she lost 1. So she lowered our total by 3. Okay, when we level, we're using unit blocks, so it is different. All right, so if we want to divide that equally over these 12 students, that 3, if we want to kind of equal it all out, we could divide this 3 that she moved over the 12. So if we were to take those 3 extra and divide it by the 12, because we want to add it back, right? 3 divided by 12 is going to give us 0.25. We need to add that back to each tower if we want it to be the same. So what she did, because they say here, now discuss how her idea could be used to make a correct statement. So here she's got 6, 6, 6, 6, 7, 7, 7, 7, 8, 8, 8, 8. And that doesn't work, right? This is 3 too low by 3. But if we want to even it out, we said, hey, if we need to get it back up by 3, we can give each one 0.25. So if we make this 0.25, 0.25, 0.25, 0.25, if we make everybody 0.25, then we can really even it out. And let's check and make sure that works. So now we're saying, okay, 3 times 6.25 plus 3 times, I'm sorry, there's 4 of this. 4 times 7.25 plus 4 times 8.25, all divided by 12. So let's type it in. 4 times 6.25 plus 4 times 7.25 plus 4 times 8.25, enter, divide by 12, we get 7.25. So that would work. So she was kind of on the right track, but not really, because these aren't units. They are different numbers. So go ahead and complete all of these. There's 1, 2, 3, 4, 5 problems. Don't skip any of them. Press play when you're ready to see the solution. Take your time. And there we go. All right, let's move on to the median. A median is another measure of center. So to calculate the median of a list of numbers, we're going to organize the list from smallest to largest. Or largest to smallest, but this is your step 1. And this is usually the step that people forget, and that's why they make a mistake. The middle number is the median. So if I were to do this, that's not 7, 10, 11, 8, 10, bum, 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 I would say the median is 11. That would be wrong. To find the median, first I would rearrange it from smallest to largest, and then I would find the middle. And I do it slowly. Take from the bottom, and top, and then I get my median. Now, if you have an odd number, that works out really nice. But if you have an even number, let's look at this example. So bottom, top, you would take your 2 numbers in the middle and you would find the mean. 4 plus 5 divided by 2. So that would be 9 divided by 2. We would get 4.5. Let's do an example. Determine the median for this set. So 6, 6, 7, 8, these look all in order. So bottom, top, pause. That's going to be the trick. Bottom, top, pause. Bottom, top, pause. Bottom, top, pause. Bottom, top, pause. That is the median. The median is 12. Now here, this list is not in order. So first, I'm going to list it in order. 2, 3, 4, 6, 7.1, 8.1. And then I'm going to count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You'd be amazed how many data points you're going to lose along the way. So now bottom, top, pause. Bottom, top, pause. And I'm left with 2. So I'm going to add them together. 4 plus 6 is 10 divided by 2. My median is 5. So what is the difference between the median and the mean? The mean and the median are both single number summaries of a set, and they give us a sense of what is typical, but they might not be the same, and you're going to see that in the next exploration. So go ahead and complete this exploration, press pause, and then press play when you're complete. So when we talk about the median, it is not affected much by a few pieces of data that are very far outliers. The median is not affected by those, but the mean can be significantly affected. So when we have this data all close together, they have actually the same median and the mean. But when we have this data with this outlier over here, the median was not affected, but the mean was pulled to be higher. Okay, because of the mean sensitivity, the median sometimes can give us a better sense of what is typical based on if we have any outliers. So if we're talking about the household income of families, the median is going to be preferred because we're going to have people who have a lot of money and they're going to pull the mean up. So a median is more typical. But on the other hand, the mean is a better choice when a total amount is to be calculated from the representative amount. So if we were to talk about the total incomes, we should multiply the mean household by income by the number of houses. If we multiplied the median number by the number of houses, we would get a value that is lower. So some problems, we may want to use the mean. Go ahead and complete this exploration. Press play when you are done. So to help us remember which is the median and the mean, think of this example. On the road, the median line is the line down the middle. Similarly, the median is the middle of all the data values when they are put in order. Complete this U-try, press play when you're ready to see the solution. And there we go. Some common errors. Students who are beginning to learn statistical concepts may mistakenly try to apply the median where it doesn't apply. So first, the median and mean apply only to numerical data, not categorical. If we're asking about favorite sport and they draw a bar graph, they might say a median favorite sport. It's not possible. You cannot have a mean favorite or a median favorite. It doesn't make sense. It would not make sense to consider a balance point on a bar graph or categorical data. Explore this here and then press play when you are done. So when data is displayed in a dot plot or histogram, students sometimes calculate means and mean incorrectly by finding the frequency count rather than the data. So look here. They grabbed 6667777. That is correct. But a student incorrectly might say that's 1, 2, 3 plus 1, 2, 3, 4, 5 plus 1, 2, 3, 4. So we want to make sure that we're making sense that we're actually using the data and not the frequency counts. Complete this U-try, press play when you are done. And there you go. And we'll close this section by talking about the mode. The mode is the most frequent in the list. It's possible to have no modes or many modes. In this example here, the number 11 occurs 3 times. That's more than any other number, so 11 is the mode. Statisticians do not use the mode as much as the mean or median because relatively small changes in the data can produce large changes in the mode. Unlike the mean or median, the mode can be used in categorical data to identify a modal category or the most frequent category. So if we were thinking about the most favorite, that would work. So you can get a measure of center and it would be the mode with categorical data, but it cannot be the mean or the median. And that concludes section 15.3.